Friends, our next topic is Newton's laws of motion. Newton's laws of motion. Three laws was given by Newton, which are known as Newton's first law, Newton's second law, and Newton's third law. These three laws are combinedly known as Newton's laws of motion. Newton's first law of motion. According to this law, if a body is stationary, then it will remain stationary, and if it is moving, then it will move with the same velocity and in same direction until and unless an external force is applied on it. It means this law gives the qualitative definition of force. According to it, the force is that external cause which tend to change or actually change the state of motion of the body. Here we have a body and a coin is placed on it. Now we apply a force, so the body moves in forward direction and the coin want to remain in its position, so it will fall down. This law also provides us the concept of inertia, and the concept of inertia was given by Galileo, and hence it is also known as Galileo's law of inertia. Now, what is inertia? Inertia is that inherent property of a body due to which a body opposes the change in its state of motion. Inertia is directly proportional to mass. It means greater the mass, larger is the inertia. Types of inertia. There are three types of inertia. First one is inertia of rest. Second one, inertia of motion. And the third one is inertia of direction. Now, inertia of rest. It is the inability of the body to change its state of rest by itself. It means if a body is at rest, it will remain at rest. Now, example of inertia of rest. A person standing in a bus falls backward when the bus suddenly starts moving. The dust particles inside a woolen blanket fall off when it is beaten by a stick. So these are the examples of inertia of rest. Inertia of motion. It is the inability of the body to change its state of motion by itself. It means the body wants to remain in its motion. Now, example of inertia of motion. A man getting down of a bus falls forward when the bus suddenly stops, because the upper portion of the man wants to move continuously, whereas its lower portion, which is in contact with the bus, suddenly stops. So the man wants to continuously move with the direction of bus. A ball thrown upwards in a running train continues to move along with the train. Now, the inertia of direction. Example of inertia of direction are when a car suddenly takes a turn, the passengers are thrown in the outward direction, and a body released from a balloon rising up continues to move in the direction of balloon. Newton's second law of motion. According to this law, the rate of change of momentum is directly proportional to the applied force, and the change in momentum is always takes place in the direction of applied force. If F is applied force and P is linear momentum, then according to Newton's second law of motion, F is directly proportional to dp by dt. When we eliminate any proportionality sign, then there is always an equal to sign and a constant of proportionality. Here we use constant of proportionality 1, so F equals to dp by dt. Here P is linear momentum, and linear momentum is actually the product of mass and linear velocity, so P equals to mv. Here m is mass of particle and v is linear velocity. Now, if we substitute P equals to mv from here to here, then F is equal to d by dt of mv. In this case, mass does not depend on time. In some cases, mass depends on time or mass changes with time, but here we are taking a special problem in which mass does not depend on time. So F is equal to m dv by dt, and dv by dt means the rate of change of velocity, and the rate of change of velocity is known as acceleration. So dv by dt is replaced by a, so F equals to ma. Here a is the acceleration of the particle or acceleration of the body. Thus, Newton's second law gives the quantitative definition of force. It means by using Newton's second law, we can find the amount of force applied on the body. Whereas Newton's first law gives the qualitative definition of force, according to which push or pull is known as force. If ax, ay and az are the components of acceleration in x, y and z directions respectively, then F is equal to m ax I cap plus ay j cap plus az k cap, or m ax I cap plus m ay j cap plus m az k cap. Here I cap, j cap and k cap are the unit vectors along the x, y and z directions respectively. If max equal to fx, may equals to fy, and maz equals to fz, where fx, fy and fz are the components of force along the x, y and z directions respectively, then F is equal to fx I cap plus fy j cap plus fz k cap. Since Newton's first law and third law can be derived from second law, and hence this law is the real law of motion or the most fundamental law of motion. Since F equal to ma and hence A equals to F by m, or acceleration is inversely proportional to mass. It means greater the mass, smaller is the acceleration produced by a body. Since mass is the measure of inertia of the body, therefore the mass given by this equation is known as inertial mass. Please note that acceleration produced in the body depends only on its mass. It does not depend on the initial or final velocity. Unit of force. Since F equal to ma, so unit of force will be unit of mass into unit of acceleration. In SI, unit of mass is kilogram and unit of acceleration is meter per second square, and hence the unit of force will be kilogram into meter per second square, and it is known as Newton. In CGS system, unit of force is Dian, and the relation between Newton and Dian is 1 Newton is equal to 10 to the power 5 Dian. Dimensional formula. Since the dimensional formula of acceleration is m naught L t minus 2, and hence the dimensional formula for force is m L t minus 2. Accelerated motion. There are two types of accelerated motion. One in which only the magnitude of velocity changes, and another in which only the direction of the body changes. If only the magnitude of velocity of the body changes in a motion, then in this type of motion, the force is applied either along the direction of motion or opposite to the direction of motion. If only the direction of the motion of the body changes, then in this type of motion, the force is always applied at right angles to the direction of motion of the body. Circular motion is the example of this particular type of motion in which only the direction of motion of the body changes. Newton's third law of motion. According to this law, every action has an equal and opposite reaction. The action and reaction act on different body and they are always simultaneous. It is not possible that we will apply action today and the reaction happen tomorrow. The action and reaction are always simultaneous and acts on different body. So according to Newton's third law, to every action there is an equal and opposite reaction, and hence the third law are also known as action-reaction law. Now we will discuss some example. When a bullet is fired from a gun, the gun recoils. Here we have a gun. A bullet is fired from it and the bullet is moving in right direction, and due to this action there is an equal and opposite reaction and hence recoils. The action and reaction are always equal and opposite in direction. So here we have action and as a result there is a reaction. When we move on a road, we push the road from our feet in backward direction, and as a reaction the road pushes us to move in forward direction. Now there is another example. When a swimmer swims into water, then he pushes the water by his hand, and as a reaction the water pushes the swimmer in forward direction. Here we have a swimmer. He pushes the water in left direction and as a result he moves in forward direction. So here we have reaction. So this is action and this is reaction. Action is in left direction and reaction is in right direction. When a gas comes out from the back of the rocket as a jet, it provides the upthrust to the rocket as a reaction, and hence the rocket moves in upward direction. Here we have a rocket and this is a jet which is moving in downward direction. So the jet is moving in downward direction and as a reaction the rocket moves up. The jet is going in downward direction and rocket is moving in upward direction. Please remember that the action and reaction never cancel each other, and the Newton's third law contradicts theory of relativity. According to Newton's third law, the force signal can travel with infinite speed, whereas according to the theory of relativity, nothing can travel with the speed larger than the speed of light. Here we end our session. I hope you enjoyed this session. So please like, share and subscribe our channel. Goodbye.